Okay, so keep in mind there are different ways of notating multiplication. A lot of times we start out with this type of notation with that X symbol for times, and oftentimes we move to this dot symbol. There are some cultures that would actually write the lower dot like that. And for those cultures, a lot of times, so in the way that we're doing it, this would actually mean this would be a decimal point. And we'll talk about what that means later. But that's essentially, that makes this a number that's between 3 and 4. This is 3 and 7/10. Okay? So, but there are some cultures that make their multiplication a lower dot like that, and oftentimes those cultures will use a decimal comma this would mean 3 and 7/10. And so I'm not, like, if you do not if you are not native to a culture that uses a decimal comma, then don't worry about it. Just be like, I'm just saying this mostly for the people who have a cultural history of actually having a lower dot used for multiplication. Okay, and just to know, like, we're going to use the middle dot. This is a middle dot. Midline dot. Okay, that's going to be our practice here. I'm going to go ahead and take this out. All right, so we can also kind of use this juxtaposing. I think juxtapose is not the right word. It's not concatenation. I don't know what the word is right now. But if we write quantities next to each other, a lot of times that means multiplication. And this can actually make sense in terms of like how we mean 3 times 7. Like, we can see this as 3 sevens. You know, this is like 3 copies of 7, or you can read this as 3 sevens. All right, and this notation here, we maybe have talked about this a little bit in the past. That is usually used in computers. So if you ever need to do multiplication, either, well, like in some sort of program where you actually have multiplication, we don't have this midline dot as on our keyboards, so we use this asterisk, which I believe is above the 8 key. Let me double check. Yes. This is Shift 8. So if you're ever doing calculations in, say, a spreadsheet or something, and you need to do multiplication, then you will use that asterisk. All right. So when we write multiplication, when we're using variables, we pretty much never write any symbol. We just use that writing symbols right next to each other. So I would write AB to mean A times B. Okay, I wouldn't actually put a symbol in between them unless there was some question in the context where, like, I needed to clarify this is definitely multiplication, and I wanted, like, anybody who was reading it to know unambiguously that this is multiplication. But in general, we just write those symbols next to each other to indicate this means multiplying the quantity A times the quantity B. And this kind of, like, it's helpful. It really is helpful, because now if we look at 3x, so I read it as 3x, and it is 3 times x, right? So if I just write those symbols next to each other, it means 3 times x. But 3 times x means adding up 3 copies of x, okay? So I often, when people are getting accustomed to the algebraic notation, I really encourage you to read this as 3 x's. Okay, so this is adding up 3 copies of x, or 3 x's. And so here's a picture of this. If x is a variable, okay, and so we don't know where x is on the number line, but I'm just going to say here is x, and here's what it looks like to add an x, and here's what it looks like to add 3 x's. Okay, so whatever, I don't know what the scale is on the number line, but if this is what x looks like, then I know that this is what 3 x's looks like. All right? So as a side question, where is 10 on this number line? Think about that for a minute. Okay, so we actually don't know where 10 is on the number line. So x is supposed to be a variable. It could be any number. So maybe x equals 7, or in which case 10 would be like here, right? Or maybe x equals 238, in which case 10 would be like way down here, right? It'd be even farther down, probably. So this number line isn't really a picture of a number line. This is kind of a fluid number line where we don't know the actual scale of the numbers, but we're using it to represent the adding up multiple copies of some variable quantity x. Okay, let me erase those 2 things. All right. So the answer to this question is we don't know. Since x is a variable, so its quantity can vary. Its value can vary. Okay, and in this picture, it is important to notice that we drew the picture for a positive value of x. And so I intentionally put like a little plus sign here and a minus sign here to indicate that this is, the positive goes to the right and the negative goes to the left. That is our convention. And it's not an unmovable convention, but it is the convention. So what would it look like if x was a negative number? So if x is a negative number, then x would be like somewhere over here. And this would be adding some value of x. Okay? This is where x is a negative number. Okay? So don't get confused by this plus. I'm adding a value of x, just like, if I had a picture of 1, 2, 3, 4, 5, negative 5. Here's the number negative 3. And this would be the same as, this would be a motion that showed adding negative 3, okay? The value is negative 3, and I'm adding that value. So think about this piece being hidden inside the box of x, okay? We don't necessarily see what the value is, but we are adding that value. Okay? So this is what it would look like if we have, if x is a negative number, we're adding an x, and then we're adding another copy of x, and we're adding another copy of x. So this would be 2 x's and 3 x's. Okay? This is 3 copies of x where x is a negative number. Okay? Don't be fooled by the fact that this 3 is a positive number. Okay? This is 3. If x is a negative number, then 3x is a negative number. Okay. So here's a picture of negative 3x if x is a positive number. So if this is adding x, then this would be subtracting x. And so this would be then subtracting 2 x's and subtracting 3 x's. All right, and that's assuming that x is a positive number. All right, so now, let's see. Oh, I think I did that already before. So if this is the value of x, then I'm assuming that x is a negative number. So adding 2 copies of that. So this would be then adding an x. All right, and adding 2 of those, I should actually, and I'm going to do this. The cheating way with my tablet, but I do this intentionally because it's also, you know, I'm kind of emphasizing the fact that I am taking a direct copy of that same value. So the same, it's exactly the same length there. Okay? So, and I'm going to take one more copy of that. So there are 3 copies of x. All right? And then this would give, this is 2 x's. And then this would be 3 x's, 3 copies of x. 1 copy of x, 2 copies of x, 3 copies of x. All right? Now, here is a copy of x. Okay? Now there are different ways of reading this. How would you read this quantity out loud? You could read it as minus x. You could read it as negative x. Or you could read it as the opposite of x. Remember, we use that minus symbol to also indicate the opposite of a number. All right? And calling it negative x, I've seen that trip a lot of people up because they want, if they say it's negative x, they want that to be a negative number. But if x is a negative number, then negative x would be a positive number. So this, calling it negative x can lead to confusion. So I would actually say, I would favor calling it the opposite of x. Maybe I should put a little star rather than an asterisk. I would call it the opposite of x. So if this is where x is, then the opposite of x would be in the opposite direction on the other side of 0. So this would be the opposite of x. All right? And then, again, we did this before, so this is, if this is adding an x, then subtracting an x would go in that direction. Okay? So it would be subtracting 3 x's or adding 3 copies of negative of the opposite of x. So here would be a negative x, or the opposite of x. And then adding another copy of the opposite of x would give us negative 2x. And there is negative 3x. This is for x being a negative number. So all of these distances should be the same, okay? And again, we don't know what the scale is, right? X might be negative 5, x might be negative 417, okay? In which case, we're going positive 417 3 times. Okay, so we don't know what the scale is, but this is a good picture of negative 3x for some picture of where x is. All right. And I think, oh. All right. I think I'm going to say leave this to you. Well, let's go ahead and finish this. Okay. So let's make number line pictures. So 6a, where a is assumed to be a positive number. So here a is assumed to be a positive number, so and I want to make room for there to be 6 copies of it. So I'm going to put a like right here. So I start with a being a positive number, and I take 6 copies of a. Okay, so here's 1 copy of a. And I'm just going to go ahead and do the copy-paste cheat. Oops. Boop. Try this one more time. One, 2. Three. 4. 5. 6. Okay. So this should be, then we have 2 A's, 3 copies of A, 4 copies of A, 5 copies of A, and 6 copies of A. All right. Now, if A is assumed to be a negative number, I want 6 copies of A. So I'm going to make, this is going to be my A. A is a negative number now. Okay? And so this is what it looks like to add a copy of A. Okay? And I'm just going to do this by hand again. So this is A. I guess this is actually faster than using the tool. But I also like using the tool for the fact that it gets an exact size. So 1, 2, 3, 4, 5, one more. So there's 2 copies of A, 3 copies of A, 4 copies of A, 5 copies of A, and 6 copies of A. So if A is a negative number, 6 times A will also be a negative number. Okay, because I have a positive number times a negative number is a negative number. All right, and we can't see the negative in here except for the fact that A starts to the left of 0. That's the only indication that we have that there is a negative in here. Okay, so here, negative 6 times A, where A is assumed to be a negative number, so we're going to start with A being a negative number. Here's A, and I'm going to multiply A by negative 6. Okay, so if adding A is going to be like this, so this is like subtracting 6 copies of A, right? So if adding A, oops, that was not supposed to be a 6, that was supposed to be an A. So if adding A goes in that direction, then subtracting A goes in that direction. Okay, so subtract an A, subtract an A, subtract an A. I'm going to do this 6 times. Subtract 6 copies of A. 1, 2, 3, 4, 5, 6. So subtract an A. So this would be negative A, or the opposite of A, negative 2A, negative 3 copies of A, negative 4 A's, negative 5 A's, negative 6 A's. Okay? Okay, 4x plus 7x, where x is assumed to be a positive number. Whew, okay. So let's start with x is assumed to be a positive number. And I'm going to make it kind of small-ish. There's my x, a positive number. And I'm going to have 4 x's first. 1, 2, 3, 4 x's. So here's 4 x's. And then I'm going to add 7 more x's. So 1, 2, 3, 4, 5, 6, 7. So I'm adding 7 x's. So where is this going to land me? Well, if this is x, there's 2 x's, 3 x's, 4 x's, 5 x's, 6 x's, blah, 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 blah. This is going to give me 11 x's. So this should make sense. I have 4 x's plus 7 x's gives you 11 x's. Okay, 4 copies of x plus 7 more copies of x gives you 11 copies of x. Okay, negative 3m plus 5m, where m is assumed to be a positive number. So I'm going to put m here as a positive number. So start with m is a positive number. So I'm going to start with negative 3m's. So that's going to be here, negative 3m. So there's negative 1m, negative 2m, negative 3m's. Negative 3m. Okay? And now I'm going to add 5m's to that. Maybe I'll do this in a different color. And I'm going to add plus m 5 times. 2, 3, 4, 5. And where does that land me? Well, it's 1 copy of m, 2 copies of m's. 2 copies of m. Okay? So negative 3m plus 5m equals 2m. Okay? And keep in mind, since addition is commutative, this is the same as 5m plus negative 3m, and adding negative copies of m is the same as subtracting copies of m. So this is the same as 5m minus 3m. So 5 copies of m minus 3 copies of m gives me 2 copies of m. Okay, so I could have actually done that addition by first going 5 copies of m here and then subtracting 3 copies of m backwards. All right, let's go through this and look at solving equations. All right, so let's make a number line picture. So 6 copies of A equals 48. So I don't know on the onset, I don't know if A is a positive or negative number. Okay? And I could think through this and go, well, if A is a positive number, A times 6, positive 6, would be a positive number. And if A is a negative number, then a negative times 6 would be a negative number. It can't possibly be 48. So this must mean that A has to be a positive number, right? So let's put A here. And I can say, well, if I have 6 copies of A, 1, 2, 3, 4, 5, 6 copies of A, then that has to be the number 48. And maybe I know from my multiplication table, or I don't know what other ways I could know that means that A has to be 8. Okay, I mean, one way you could think of it is, well, half of that, 3 copies of A would have to be 24. And so maybe that helps me know that 3 times what number equals 24? A is, this has to be 8. Okay, so A equals 8. Now, looking at this picture, I have negative 6 times some number equals 48. And if I think about this, if A is a positive number, then negative 6 times a positive number would be negative, so it can't possibly be positive 48. So if A is a negative number, I have negative times negative would be positive. That would work out. So A has to be a negative number in this case. So I'm going to make A is there, some negative number. And this says if I take negative 6 times A, so once again I'm doing the opposite of 6 times A, or I'm removing copies of A, so this is negative A 6 times. So this is negative 6 copies of A if A is a negative number. And this is supposed to end up at 48. So again, if I break 48 up into 6 equal pieces, that means this is 8. So the opposite of A is 8, which makes A equal to negative 8. Okay, so that means A equals negative 8. And if we double check that in the equation, this says negative 6 times negative 8 equals 48. Is that equal? And yes, it is, because negative times negative is positive, and 6 times 8 equals 48. Okay, so I can say yes, that works. All right. 9m equals negative 216. So 9 copies of m equals negative 216. And right away we can think about this and say 9 copies of some number is a negative number. That's going to tell you that m is negative. Okay? So here's some value m, and if I have 9 copies of that number, I don't know if I'm going to have enough space. 3, 4, 5, 6, 7, 8. Let me start out with a smaller m. Here's m. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here is 9 copies of m. Each one of these is adding m, remember, where m has to be a negative number. And this number lands at negative 216. And if I do that division, 216 divided by 9, 9 goes into 21 2 times. 2 times 9 is 18, 36, 4. So that looks like m. So 216 divided by 9 is 24. So negative 216 divided by 9, this has to be negative 24. Okay, so m equals negative 24. Okay. So looking at this one, we have 12k minus 5k equals 63. So if I am going to go k's, so I can think about this and go, well, 12 copies of k minus 5 copies of k is going to give me 7 copies of k, right? So 7 times some number equals 63. That tells you that k has to be a positive number. So I'm going to put k here. And I'm going to actually make it kind of small because I want to draw that 12k minus 5k. So if this is k, I'm going to go 1, how about if I don't draw all of those humps? So 1, 2, 3, 4, 5 k's here, 6, 7, 8, 9, 10 k's here, 11, here's 12 k's. And I go and oops, I guess I was supposed to be doing this in blue. So then I subtract 7 k's, so minus 1, 2, 3, oops, sorry, minus 5 k's. 1, 2, 3, 4, 5. So minus 5 k's. And I have, so this is now 7 k's. And that is supposed to be 63. So 7 copies of k is 63. So 7 times what number equals 63? And we can fill that in with a 9, right? So k equals 9. And we can check 12 copies of 9 minus 5 copies of 9. Is this equal to 63? And there's a couple ways we could check this. We can actually do 12 copies of 9 is 120 minus 9 is 111? No. 12 copies of 10 would be 120. 12 copies of 10 would be 108. 108. So 10 copies of 12 would be 120, so 9 copies of 12 is 12 less than 120. Minus 25, and is this 63? It is not 63. What did I do wrong? Ah, I know what I did wrong. For some reason I plugged in k equals 5 there. It should be 9. So minus 5 copies of 9 is 45. So 108 minus 45 is indeed 63. Okay, so there's one way to check it. We can also look at this and say 12 copies of 9 minus 5 copies of 9 is 7 copies of 9. And 7 times 9 is 63, which we know. All right. So here's a funny one. So, this one is going to take some thought. So if I have an x here, and I subtract 8, well, I don't know. So here's x minus 8. And I take 3 copies of that, and it's supposed to give me negative 18, right? So I think, in fact, I want to actually start with 3 copies of some number equals negative 18. So, and I think I want to actually do this. I think I actually want to build this to scale. So I'm gonna go to negative. I'm gonna do tick marks to negative 20. 1, 2, 3, 4. Negative 5. 1, 2, 3, 4. Negative 10. So here's my negative 18. And so I know that I have to have 3 copies of some number equals negative 18. So I actually have to divide this into 3 equal parts. And if you remember your times table, you will remember that this would be negative 6. Okay, so I would be taking 3 copies of this number. Okay? Maybe I shouldn't, So here's 3 copies of some number equals negative 18. This is 3 times something. Sorry. So this should be x minus 8. This is the thing that I'm multiplying by 3, so this should be x minus 8. So that says my x minus 8 should actually be negative 6. So what does it look like to take a number and subtract 8? So if this is x, then x minus 8 would be 8. 1, 2, 3, 4, 5, 6, 7, 8 units. Oops, not like that. Subtracting 8, this would be x minus 8, like that. So that tells me that I actually have to be 2 more units to the right here. This would be, that would make this x minus 8 if this is x. right? And looking at this picture, I kind of, I encourage you to actually look at solving this equation in this way, because we can solve it piece by piece. We have 3 times something equals negative 18. Negative 18. That tells you that that something has to equal negative 6, right? Ignoring what is in that parentheses, 3 times some number equals negative 18 means that whatever's in that parentheses has to be negative 6. So the thing in the parentheses is x minus 8. So then that tells you if you subtract 8 from a number and get negative 6, that number must have been positive 2, kind of looking at the number line. Okay. And I believe this is the last one. 9 minus 7t. So let's look at this. And I'm just going to kind of do something a little bit like kind of guessing. And it's probably going to be wrong to begin with, but like starting by guessing and then refining my idea is going to help me understand it. So if I start at 9, and I don't know how big t is, say t is like this. Say that's t. If that's positive t, then that would be negative t. So if I do, why do I say minus 6? So if I do that, starting at 9 and then subtracting t, so there's minus 1t, 2t, 3t, 4t, 5t, 6t, 7t, that's not going to work because it looks like I'm supposed to end up at 30. But 30 should be this direction from 9, right? So that tells me, in fact, that t can't be a positive number. I know that 9 plus a quantity equals 30. I have to go to the right of 9 to get 30. So that tells me that subtracting t should be in the positive direction, so t should be in the negative direction. So let's actually change it to be this way. Let's say t is a negative number. So subtracting t would be in the positive direction. So I'm going to subtract t, 3, 4, 5, 6, 7. So I'm going to subtract 7 copies of t. So I'm assuming that t is some negative number, and this would land me then at, this would be 9 minus 7 copies of t. Starting at 9 and then subtracting 7 copies of t, and then that would give me, supposed to give me 30. All right? So that tells me, so I can also think of this, remember, I can see this as 9 plus negative 7t, okay, equals 30. Well, I know what to add to 9 in order to get 30. That has to be 21. So that tells you negative 7t has to equal 21, which means t has to be, what do I multiply by negative 7 in order to get positive 21? It should be negative 3. Okay, so I'm looking at t is negative 3, so the opposite of t would be positive 3. Let's check this. Check. Is 9 minus 7 copies of negative 3 equal to 30? I am phrasing this as a question. I'm putting equals question mark to phrase it as a question rather than as a statement. So 9 minus 7 copies of 3 is the same as adding 21. 9 plus 21 equals 30, and that works. Done.